All right, the first thing that we're going to talk about today, guys, is what a radical is. And my definition may be a little bit different, but it's basically the same basic term. A radical, let me turn down my font size. A radical, guys, it's an operator symbol, okay, and it indicates that we should take the root of a number. Now, there are many other operator symbols, guys. When we hear operator, a lot of times you think of operations, add, subtract, multiply, divide. Okay, we're going to look at some other operator symbols in just a little bit. All right, so after looking at each of those operator symbols, like I said, you guys should be familiar with. You've got the square root, division, brackets, parentheses, exponent. Okay, now we're going to start actually looking at the different parts of a radical. Okay, if you guys remember a couple weeks ago when we were talking about sequences, okay, when we were finding the nth term, you guys know that n, okay, stood for any number. Okay, well, you can find the root of any number. You guys primarily think of square root, but there are other roots as well. Okay, but the nth root of a number, a, which a is just a value, can be written as a radical expression like is shown there or right here in the diagram. So the first thing that we're looking about, guys, that n, that is considered to be our index. Okay, and that can be a 2. It's understood to be a 2 if there's nothing there, but it could also be a q for cubed root. It could be a 4, which we're not going to get into any of that, but it can also be other numbers outside of just a square root. Okay, this, the symbol, the actual symbol, guys, like we just talked about, that is my radical or the root. Okay, just a little basic term for you guys to familiarize with. And then a, the a is what we call a radicand. Okay, but the biggest thing that I like to look at it is it's just a value. It is just a numerical value that we're looking at. Okay, now, like I said earlier, if there is no index, if there is no number there, that is understood to be 2, the number 2. Okay, so when people start talking about this is the square root, if there's no number there, guys, it's really essentially saying that there's a 2 there, and we're going to talk about what that means. Okay? All right, now the next thing we're going to look at, if a radical has more than one root. Okay? Now, we're going to do the most basic one right here. What is the square root of 4? 2. You guys know that? It could also be something else. It's the same number times itself. What other number could that be?
1.
1 times 1 gives you 4? It's not as hard as y'all are making it out to be. -2, okay? So anytime, guys, it could be -2, okay? But just know that anytime it has more than one root, like here we have 2 and -2, the radical sign indicates only the principal or the positive root, okay? So anytime that it doesn't specify, we're just going to assume or understand that it's going to be 2, okay? Now, right here, we're going to list out the first 12 perfect squares, okay? So, can you take the square root of 1? What's the square root of 1? 1. Okay, so yes, we can, right? Okay, so 1 is a perfect square root. Can you take the square root of 2? What about 3? 4? Yep. 5, 6, what times what gives you 6? Same number. Is there one? Then say no. 7, 8. Nope. 9. Okay. 10, 11, 12, 13, 14, 15, 16. Anybody see the pattern here? What's the next one going to be? 25. And the next one? 36 and 49 and what? And good. Now, we're not going to list out 12. I want y'all to scratch that out. We're going to list 20. So we listed there, out from there, from 144 out to 100. Those are the first 20 perfect squares. Now, I'm going to take my drawing tool and just make a very simple note. Okay, this is the first one. The square root of it, okay, is 1. The square root of 100 is what? 10. It's obviously the 10th one. Okay, 400 is 20. Now, I'm simply just going to find some middle points in between there. We know 25 is 5. Okay, and then 225 is 15. Now, I'm putting these here so you guys can have a starting point when you're looking for some of these or wondering what the square root is without having to figure some or work too difficult or work too hard to get them. Okay? It's just a little bit of a starting point, almost like a little bit of a cheat sheet. Okay? Now, so those are the first 20 perfect squares, and you're probably going to use every single one of them here in just a minute. Okay? If not the majority of them. All right, so the first thing that we're looking here, guys, or really not the first, but the next thing is perfect square roots. So we just listed several or 20 perfect square roots. Now we're going to figure out these square roots and what they are. Okay, so very simply, we're just looking for the same number squared multiplied by itself. That is going to give us 81. And you guys should know that's what? 9. Pretty simple. Doesn't get any easier than that. Okay, now what about 484? It's going to be close to what? 20. And it's what? It's 22. Okay? There you should know it gives you kind of a good starting point. Or you also have a calculator, which is beneficial. All right, 64. 8. Good. All right, now here we've got a number next to the square root. It's a number next to our operator symbol. So the first thing we're going to do is take the square root, which is what? Remember that. So now we're going to have 18 times 2. And 18 times 2 is 36. Okay? I left the 18, took the square root, and then a number next to an operator symbol we know means multiply. All right? So here we know we're going to have equals 3 times square root of 256. 16. So 3 times 16. It's what? 48. Everybody good so far? All right, number 6. Okay, we're going to have negative 5 times square root of 121. 11. So then negative 5 times 11 is negative 55. Okay, all right, here. I'm going to make this real easy. We're going to split these into 2 parts. Very simple. What's the square root of 1? 1. And then the square root of 16 is 4. So it's simply 1/4 because 1/4 times 1/4 gives you 1/16. Just do them one at a time. Okay, square root of 9. 3 over square root of 100. 10. Pretty simple. Okay. All right. Square root of 25 over 7. All right, so what we just looked at, guys, were perfect square roots. Now we're going to look at some that are non-perfect, okay? That you can't take the root of evenly. Now, I'm going to give you a couple things. Now, you can look and read all of these, but I'm going to give you basically the key points, and I want you to underline these, okay? You're going to find the largest perfect square from this list. This is one of the ones that you have to use. You have to use one of these perfect squares from this list, okay? That the radicand is divisible by. So whatever number is inside the radicand, it must be divisible by one of these, okay? Then you're going to break it down. Another word for breakdown is factor, okay? Or factor tree. Okay? After you do that, you're going to take the square root of the perfect square. So whichever one of these that you used, you're simply going to take the square root of it. That's going to be half of your answer. Okay? Then, the other half of your answer, you're going to leave it just as basically a leftover. It's going to be brought down and left behind. Okay? So, very simply, I want you to write this note right here, guys. You're going to simplify non-perfect squares. Okay? This is just like using factor tree, except with roots. Roots, square roots, cube roots. Okay? Same concept. All right. Now, you're going to have to use your drawing tool simply because we don't have just a button that lets us allow to use the square root, okay, or the radical button. So, looking here at number 10, guys, the square root of 24. We know that's not a perfect square. There's no number times the same number gives us 24. But look up here in our perfect squares. Which of these numbers goes into 24? Does 1? 1 does, yeah. Does 4? Yeah. Check the others real quick. Does 9? No. Does 16? No. And obviously 25, obviously not. Okay, so the largest one that we have is the square root of 4. Now, we have to multiply this times another square root, just like we would with a factor tree. And what's the other number? 4 times what? 6. So basically, we have the square root of 4 times the square root of 6. That's going to give us the square root of 24. Okay? Now we're simply just going to continue to break these down. Can you take the square root of 4? What's the square root of 4? 2. Can you take the square root of 6? Nope. So then you're simply just left with 2. All right, let's look at 48. Number 11, 48. Okay, which of these numbers right up here, the largest will go into 48? Does 1? 1 will, but obviously it's not the largest, right? Does 4? 4 goes into 48. Does 9? 16? Yeah, 16 does. 25? 36? No. Okay, so we've got the square root of 16 times the square root of what? 3. Okay? All right. Now, go ahead and take the square root. What's the square root of 16? 4. And can we take the square root of 3? Nope. So it's just 4 times the square root of 3. Yeah. All right. So looking at 72 here, here's our perfect squares. We're going to use 36. It's the largest. So square root of 36 times the square root of 36 times what? 2. Okay? So now simply take the square root of the perfect square. And the square root of 36 is 6. And like it tells us right here, the leftover, whatever's left, we just bring it down. So it's 6 times